Thank you very much, Chabi. It is my pleasure to be with you all. I wish I spoke better Spanish. And
Um,
someday, Chabi, maybe it comes, I will come and live in Spain. You will teach me Spanish, and I will visit all these wonderful golf courses throughout your part of the world, so I can be even more useful than talking to you from the United States. I could come and learn about how you grow grass because our topic for today is about ultimately producing a playing surface for golf that performs at a very high level. I call it high performance putting surface management. If you're in the golf course business for any period of time and you don't have a beautiful setting or picture like this slide shows of the New South Wales Golf Club out north of Sydney in Australia. And I know Spain, and I know along the Mediterranean you have many courses that could look this beautiful. But no matter how beautiful the setting is, if you have lousy or bad putting greens, it's not going to be as satisfying for your customers and for the golfers. And so when I talk about high performance putting surfaces, these are putting surfaces that are firm, fast, true, stress tolerant, tolerant of high temperatures, low temperatures, diseases, insects, other pests, traffic from golfers. So high performance not only means the golfers like it, but that you are managing it so that it is very tolerant of the stress that we know our putting surfaces are going to experience. So we'll get started for our 50 minutes today. My goal is to help you understand some of the science behind managing your putting surfaces, understanding the key principles of soils. I think many times we get distracted by soils that somehow fertilizing is the most important thing. And that's an industry that has grown a lot in the turf, in golf turf, because we can soil test, get a number, and someone can tell you, oh, that number is low, you need to add fertilizer. Research is telling us now that that is not as critical as we once thought it was, especially for supplemental nutrients. So we're going to spend time talking about soil physical properties because we think that's the most important one to manage, and then understanding some aspects of mowing and rolling, cultivation, and top dressing. So that is our goal for today. I hope I'm able to make it through this without driving Carlota crazy. And for those of you who know me, I usually talk much faster than this because I'm from New York, but I don't think you'd be able to understand. So we're going to take it nice and slow. I want to start our conversation with a picture from a golf course in the United States on Martha's Vineyard that's managed organically, or I think in Europe you would call it ecologique, right? Organic or ecologique. This is a picture taking on this golf course that's not allowed to use synthetic pesticides. Much like many of the golf courses in Spain, where many of the products are labeled for agricultural or greenhouse use, but not very many labeled for putting green use or for golf course use. So what you're looking at is L93 creeping bentgrass that was seeded in 2001. I think it's August of 2001. Let me look closer. Yes, it was seeded in August of 2001, and that is the green grass to the right side of the slide. On the left side is an area that was resodded or regrassed, returfed. New grass was put in after the existing grass was killed from soil insects. We have grubs that eat the roots of the grass plants, and then the animals come and tear the grass away to feed on the grubs. So what you're looking at is sod that was replaced on top of that in 2007. that came from a location where it was produced as sod or as turf, which means it's regularly sprayed with pesticides, in this case, fungicides. The sod was then put on this golf, on the tee here that we're looking at, and then went through an entire year of growing when no fungicides are sprayed. And you see the photografia was taken on July of 2008. So 1 year after the sod was laid, 7 years after the area was seeded. And you see that the grass that was brought from the sod farm has declined and died. Why? Well, by spraying it on the sod farm, you're not allowing the plant to develop any natural resistance to this pest, which in this case is dollar spot. Dollar spot is a very big problem on creeping bentgrass. But you see the grass that was seeded there 8 years ago is not showing that damage because over the 7 or 8 years it's been seeded, it's developed resistance to the pest problems that come. So I use this slide to indicate you can choose how you want to manage your putting surfaces, but the more you rely on external inputs like pesticides, which we know you need to make pesticide applications, but if you become entirely dependent on them, when you need those plants to have resistance to the stress, whether it's disease or drought or traffic, it's not going to have that resistance if you don't train it to do that. So in many ways, high-performance turf management is not unlike training yourself for some athletic event, where you train and you train like you would for football. You train for football, you run really hard, you try many things so that when you need them in the game or in the match, you can use the skills you've developed in practice. Just with what we want to do with putting surfaces. We want to train them to be more stress tolerant so they can perform at a very high level. Sorry. Hold on. Here we go. Now this is based on a philosophy from a British plant ecologist named Professor Grimes, who published a book, Comparative Plant Ecology. And they state in this book, and it's well known among people who study plants, vegetation that develops in a place at a particular time is governed by environmental pressures. Okay? Environmental pressures. Well, what are those pressures? If we're going to talk about this on golf courses, what are the environmental pressures? Now, many times you think, oh, it's temperature, it's water, it's traffic, it might be humidity, it could be insects, it could be diseases. Whatever stress is occurring there, the play, right? The play. So maybe you play golf on a very wet day and it makes the soil wet, and when people walk and play, it becomes compacted. That is going to select for the kinds of plants you're going to grow on that putting surface. So it's stress, and many times we think about those things as environmental stresses, but they also could include human stress. Then there is disturbance, right? Disturbance, ball marks, divots from a tee when a shot is taken. But then there's also disruption that's part of regular maintenance. Part of regular maintenance. We core aerify, we verticut, we top dress, we mow. Then there are diseases that disturb the surface, right? There's many aspects of disturbance that are regularly parts of a golf course. And then there is competition, competencia. It's a beautiful word, competencia. That then is the competition of the plants that are out there. Now, if you're growing warm season grasses, many of you are growing warm season grasses, Bermuda grasses there on many of your areas. If you're growing warm season grasses, the competition is not the same as it is where you're growing cool season grasses. Now, in warm season grasses, you may be growing Bermuda grass, cynodon. You may be growing zoysia grass. You may be growing kikuyu grass, right? You may be growing paspalum. You might find mixes of those grasses, but generally in warm season grasses, they're striving for a monoculture. In cool season grasses, many times you're battling between creeping bentgrass and annual bluegrass on a putting surface. So we are always making decisions to favor or not favor a particular type of grass in the competition because they're always competing. There's also competition for resources depending on the grasses that you're growing. So stress, disturbance, and competition. These are the underlying factors that dictate how a putting surface performs if pretty much all you did was mow it. If all you did was mow it, all of these factors would be on. Now, this concept is not new. The idea of using ecological principles in a golf course was first described by Carl Ganneberger in the early 1990s when he published Turfgrass Ecology and Management. And I was just with Carl at the Golf Industry Show last week in Orlando, where the world comes together for golf here in the United States. And I was talking to Carl about possibly redoing this book because I do think it's an important text to teach us about how golf courses respond to their environment. And I think this is very important for all of you as golf course managers in Europe with not as many resources as we have for your golf courses like we have in the United States. I think it's very important for you to understand these principles. The more recent application of these concepts come from Henry Bechelet and Richard Windows, both of them at one point working for STRI as agronomic specialists. Richard, I believe, still works for STRI, and Henry Bechelet has moved on. And their goal in managing, and their idea of this disturbance theory, let's go back. The disturbance theory, what do you call it? Teoria de la perturbación. Perturbación, disturbance, right? The disturbance theory. How does disturbing the surface alter what we do? So in the case of the STRI agronomists, they believe the perennial surfaces of a fine fescue bent grass is what they want. And so they base a lot of their decisions and their management practices on their goal of this. Now, if you have cool season grasses, my goal would be that you would have a combination of creeping bentgrass, mostly, and some annual bluegrass to the extent that the annual bluegrass could tolerate the management that you were doing. I believe in some ways, if you decide how you're going to manage your putting surfaces, and you manage a particular way to meet your golfer's demands, that you will select for plants that want to survive under your management. That was the concept that I talked about at the Vineyard Club in the early slide that now has been made into this disturbance theory that if you manage a certain way and you stay true and consistent, you will select plants that will tolerate that growing environment. And so to move the ecological principles to a putting surface, grass species on a putting surface reflects the environment that is being created under preparation and play. Now here are two pictures that are indication of the environment under preparation and play. The picture on the left here, the cup cutter picture here, that is annual bluegrass, Poa annua reptans, that grows on the putting greens at Oakmont Country Club. It is very fine textured, perennial type Poa that for every purpose is a perennial plant. And it has developed on many old golf courses under regular mowing and intense maintenance. It is a Poa annua that barely grows. It doesn't grow very much. And it is indicative of what you can create if you manage a particular way for a long period of time. So that is preparation. Mowing created that Poa annua. And then there is play. And so when you are playing golf like this man is doing on this golf course that's clearly dormant, you are disturbing that surface at a time when the grass isn't growing. And therefore, it allows grasses that survive under regular disturbance and can regrow very quickly to be more successful under these conditions. And that is an ideal condition for annual bluegrass to invade when the turf is not, when the bent grass is not actively growing, or in the case of your warm season grasses, when your warm season grasses are not actively growing and they're getting disturbed, that other weeds and plants might move in. So disturbance also can play a role in warm season grasses as well. So again, course play and course preparation. Disturbances or perturbaciones, you see them in the ball mark here on the left with the golf ball on a wet putting green that disturbs and exposes the soil, that will allow weeds, annual bluegrass in particular, to develop in that ball mark. And then we do preparation. We core air fry. We use the cultivating device here, pull up a plug, and disturb the surface dramatically. That has a benefit, but also is part of the environment that selects for the plants that you grow there. So if you are managing cool season grasses, and I'm assuming many of you are in fact managing cool season putting surfaces, I would hope, in many parts of the country, that where you're doing that and the concern says, well, we're getting too much Poa annua, we must regrass to a better bent grass. What I have learned is just getting a better bent grass is not always going to be the solution, because that bent grass is going to be disturbed, because that bent grass surface is going to be disrupted. That bent grass may not like some of the stress that you give it. But if you are able to determine what is the best way to manage the perennial grass, the bent grass in this case, and you target your management to that, even if annual bluegrass comes in, it has to tolerate being managed like your perennial turf. Now, one way to deal with weed problems when they come in is to take them out. These are course managers, course employees, course staff at the Royal Melbourne Golf Club in Melbourne, Australia, where they have a wonderful blend of fescues and bent grasses on these old putting surfaces at the Royal Melbourne from the 1920s when it was built. And you can see what they are trying to do to keep the annual bluegrass from becoming a problem. They walk on their hands and knees with little jars of glyphosate or Roundup with a little bit of blue dye in it, and they spray the spots. And you can see the light yellow spots that they've already killed. So, of course, one way to deal with competition is through excluding it like this. Or it is developing herbicides like methazolin, or Poacure is what it's going to be called, that kills the annual bluegrass pre-emergent and post-emergent. So this is a very exciting chemical. Whether it will ever come to the market in America and then come to the market in Europe is unknown. But this is a chemical that can be used to keep annual bluegrass out of putting greens. And one of the beauties of it is that it kills the annual bluegrass very slowly. See, if you're going to kill annual bluegrass on a putting green, if an herbicide works really well, it will kill it immediately. And then you have a lousy playing surface. What you want is the plants to be killed slowly so the competition can fill that ground uniformly and maintain a good putting surface. So this chemical has been designed to kill the annual bluegrass slowly, if it ever comes to market. Even if it does. Here's a picture from Jim Brosnan from the University of Tennessee. This is a glyphosate-resistant Poa annua plant. On the right is a plant that is not killed by glyphosate or Roundup. On the left is a sensitive plant. So if you rely on chemicals, eventually those chemicals will begin to have problems, and we are learning about this a lot in the United States with genetically modified agricultural crops leading to many herbicide-resistant weeds. So one way that we try to address more stress-tolerant perennial surfaces is to blend and look for grasses to blend together that together are better than they are apart. And so you pick grasses that you would put together to make the blend better. Now, here is a blending strategy that should only be used to reduce disease incidence when the susceptible cultivar has desired attributes that are not possessed by other components in the blend. So Crenshaw creeping bentgrass is very sensitive to dollar spot. And you see the measure here on the axis, area infectada. So the greater area infected means it gets more dollar spot. So Crenshaw, very susceptible to dollar spot. L93, very resistant to dollar spot. When you put them together, you see that the Crenshaw gets better for dollar spot, but the L93 gets a little bit worse. Now, it could be the Crenshaw L93 blend gives you a really nice playing surface, but it's a little bit weaker for dollar spot. You would have to make decisions on how you want to blend grasses so they would perform really well. So, to summarize this, I'm willing to live with some diversity because over time, diversity stabilizes an ecosystem. What do I mean? Here's the picture of an old putting green of almost all annual bluegrass in Ireland. They wanted to put USGA putting greens, sand root zones underneath these greens to improve the drainage. But they liked the Poa annua they were growing because it had developed over a long period of time. Now you see some of the pictures here. You can see there's a little bit of Microdochium nivale, Microdochium patch in the picture here. But still, the green does very well with very little chemicals. So they took the sod off, built the USGA green profile, and then put the sod back on. And it's because they really liked the grasses that they had. So in many ways, this part of my talk, the first part of my talk, is about making sure you understand the plants that you're growing and how they respond to the things that you're doing. And in Europe, because you don't have the same kinds of resources we might spend on golf, you have to learn more about how your grasses might do with fewer inputs and really understand how they respond to water and fertilizer and mowing, even better than Americans have to because we spray pesticides like crazy in this country. And I believe that that is going to change very rapidly in the next 10 years. And we have been talking about this ecological approach to managing putting greens for a long time. Now, why is this important? It is important because here is a football pitch in the northeastern part of the United States, growing last year in 2016, one of the driest years in the last 200 years, historically dry. We flew a drone above this football pitch last summer and took a picture of the irrigation system. And you can see in this image the circles around the sprinkler heads that show very clearly how poor the irrigation system was working. When you have the climate changing the way it is, longer dry periods, warmer periods, anything that provides a very strong stress on your turf system, it will expose your weaknesses. So when you get in very dry periods of time, you become reliant on your irrigation system. If your irrigation system is not very good, you will see how poorly it performs when things get very dry. What we are finding is, because it is not dry very often in the northeastern United States, our turf managers don't see the weaknesses of their systems very often. And so consequently, when they get a dry period, you can't necessarily see you now see the weaknesses of this system. So it's very important to understand these weaknesses, which in many cases are going to be related to your irrigation system and the soil. So let's talk a little bit about the soil. Many times people will talk about soil chemical properties and soil testing, and we should base our testing on soil test information. But I think there's there is a growing sentiment among many of the best turf managers in the world that we really don't know exactly how to use soil testing to determine nutrient management programs. Because many times nutrient management programs are set up to determine the agronomic maximum, not necessarily the maximum that we're interested in. If you look at this graph, you maximize yield somewhere in the 150 to 200 pounds of potassium per acre. That's where you get the most corn yield, right? Yield. Well, we are not in the yield business. We are in the golf course business or in the turf management business. And so in the turf management business, we get paid for our surfaces performing really well. The ball's got to roll good. They got to be firm. They got to roll true. They have to hold up under traffic. They have to have decent color. I'd like them to not get so much disease. I'd like them to be dense during traffic and not have weed problems. So I have different goals than a corn farmer for the way I fertilize. But many of our soil tests are based on soil testing that's based on agriculture. And so consequently, I have a lot of questions about the value of soil testing. So here is my good friend Doug Soldat, is a professor at the University of Wisconsin, former student of us at Cornell. Went to Wisconsin and built a sand green with creeping bentgrass planted on it. And he didn't apply he did not apply phosphorus for the first couple of years and allowed a phosphorus deficiency to develop. And so you can see in this plot, when the soil test value comes up at the 3 to 5 part per million range, that there's not enough phosphorus. However, as soon as you get to 7 part per million, you see that the plot looks perfect. You look at 11 and 17 and there's virtually no change. One of the things we're learning now about soil testing is for creeping bentgrass growing on sand in climates like Wisconsin, it looks like once your soil has 7 parts per million phosphorus in it, you have enough. Adding more doesn't do any good. And many people will tell you about this ideal soil. They will talk to you about the base cation ratio. They will talk to you about available and exchangeable. And they'll tell you this is an ideal soil that someone decided to publish a paper on many years ago. And I can tell you this, if you promote this type of philosophy of this ideal soil versus what does science say, you will apply more fertilizer. We know now that by interpreting soil tests in this manner, with wanting 85% calcium on certain sites, 12% magnesium, 5% potassium, if you use this as a model, you will sell a lot of fertilizer and have virtually no impact on the quality of your turf. Two scientists got together and looked at various ways of looking at soil testing, including the base cation saturation ratio, and found none of the claims that are made for this being an ideal soil, because they were designed to produce an ideal soil, was investigations of the amount of calcium for optimum growth of alfalfa in New Jersey. It works good for that. It doesn't work good for anything else. So what we are promoting is the use of the minimum levels for sustainable nutrition promoted by Micah Woods, Larry Stoll at the Pace Turf Institute out in California. I would say these are the target values for your fertilizers that you should be meeting. And if you're at or near these levels, don't apply fertilizer. There's very little need for the amount of fertilizer we have been using in turf, warm and cool season grass turf, for a long time. So this is the part of the presentation where I'm telling you, don't pay attention too much to your nutrients, because nutrient deficiencies are not big problems on golf courses. Now, having said that, there's two things that are important. If you have problem irrigation water, or you have sodium in your irrigation water, you should test your water regularly and test your soil regularly to monitor your sodium levels, and then adjust your fertilizer program to address those sodium issues. That's it. After that, the only thing you've got to pay attention to is nitrogen. And there's a very simple way of looking at nitrogen. What you apply, what you lose. Annual nitrogen surplus means you get too much growth. You might get some leaching. Nitrogen deficiencies, you might see a decline in quality. It doesn't hold up under stress. So you'll want to balance and manage your nitrogen. This is the nutrient that you need to pay attention to. And remember that stress, after nutrient management, we use stress all the time on putting greens to get to that high performance level we're looking for. We want them to perform well, so we dry them out and the roots grow deeper. We want them to perform well, so we mold them lower so they're denser. We verticut them so they get dense. We roll them so it helps manage organic matter. We use stress all the time. Don't be afraid of a little bit of nutrient stress. And in the case of annual bluegrass, if you're growing a lot of annual bluegrass, like we've been doing for many years in the northern climates, you don't have to wonder about if you got too much stress, because you will get basal rot anthracnose, and it will be a barometer for the stress, because you only get this disease when your turf is under significant stress. So if you're struggling with basal rot anthracnose, it's unlikely you're struggling with many things that a pesticide will save. But if you look at the best work that's going on at Rutgers University here in the United States regarding anthracnose, they will tell you much of the problems they've seen with basal rot anthracnose are related to nitrogen fertility. Do not skimp on your nitrogen, but you don't have to put excessive amounts of nitrogen. Don't try to keep the nitrogen off your putting surfaces if you need the turf to grow. If you think it's going to be faster by not fertilizing it with nitrogen, that's fine. If you want a fast putting green without fertilizing with nitrogen, that's fine. But you need to understand how risky that can be. Now, after nitrogen management, when we're talking about green speed, the USGA has published many good articles on this topic. Let's talk about the performance that golf superintendents are looking for now and the targets that many of our golf superintendents are having to achieve. And so this was a survey conducted very recently by golf course superintendents in the New York City metropolitan area, very affluent, high-end private golf clubs. And they are saying these are the green speeds that they're expected to achieve now. 11 feet 3 inches is considered medium, and they're not fast now until they're 12 and a half feet. Now, I know this is the kind of language, no matter where you are, you speak about green speed. But it's interesting for you to see green speeds that we're trying to achieve now. And one of the things we've learned you can't do is you can't rely on golfers to tell you how good the greens are from a green speed perspective. When you look at this study conducted in Connecticut, at the University of Connecticut by Bill Dest in 2010, where they surveyed about 450 golfers, 450 golfers that played on putting greens where the green speed was known. They knew the ball roll distance. And when you look at the slide, you see that regardless of the handicap, all golfers, 70 to 80% of the golfers, underestimate green speed. They always think the greens are slower than they are. And especially if you look in this under 10 handicap, when you look at that particular group, they are the most likely to underestimate. The best golfers always think the greens, or 80% of the time, think the greens are slower. So you want to be careful when you're setting your performance targets that you set them and communicate them to the golfers in a way that knows that they always underestimate how good the greens are. Now, green speed is something that has to be understood not just for performance, but also for pace of play. We've learned now over the last several years that pace of play, how quickly golfers play, is impacting how golf is enjoyed by people. The United States Golf Association has been studying pace of play using data and GPS devices to determine where golfers walk on a golf course. We have been starting to do this with managing equipment as well. So they put these GPS devices on the golfer, and then they trace where the golfer goes, and they can determine how long the golfer takes to play golf. And one of the things that came out from the 15 golf courses that they did this research on, it showed very clearly that when you raise the green speed from about 10 and a half feet to 11 and a half feet, you're adding about 20 minutes, 25 minutes, almost 30 minutes in some cases, 25 minutes to how long it takes to play golf. So another half an hour of extra time on the golf course when the green speeds are very fast. So be careful when you set your targets for performance, because some of that is going to potentially impact the time it takes to play golf. And that's a growing concern, and where, putting surface performance and management come together. So what else does the golfer help us with? Oh, sorry. There has been a fair amount of data talking about golf shoes. And we have been looking at golf shoes now for a little while, for a year, to look at their effect on putting surfaces. We've tested the Adidas, the FootJoy, and the FootJoy spikeless type of shoe. And we've been looking at the damage that these shoes create. So you can see the Under Armour and Adidas shoe. Under Armour and Adidas looked very similar. You can see that plot up here in the top left of the slide. The FootJoy DNA, not as bad. The spikeless shoe causing some damage. And the bottom right is where the plot receives nothing but maintenance traffic. So you see 3 shoes and the putting turf after 8 weeks of traffic. And so we're seeing high performance putting surfaces are very much impacted by the golf shoes that are playing on them. And here they are. This is the spikeless shoe from week 1. You see at week 5 on the top right here how bad the turf looks. That's right after the bent grass surface received about 1 inch of rain, or about 25 millimeters of precipitation. Where the turf starts to thin, you start to see some algae growth, and that's related to footwear. So as if it wasn't hard enough, the soft spike traffic is starting to become a big issue even on spikeless shoes. So let's talk for a second regarding high performance putting surfaces relative to the mowing research. Now, we have been studying mowers for quite a while, as has my pal John Sorokin at the University of Tennessee and Tom Nicolai, our friend up at Michigan State University. We've been looking at what they've been looking at for a number of years. And many of the things that we've looked at in mowers, one of the things we think had potential big impact on turf performance, that is the bed knife position relative to the center line of the reel. So you've got the center line of the reel here, and you have the possibility to move the bed knife back, away, and forward towards that center line, which then allows the entire reel to tip into the putting surface. So here are some really nice slides that John Deere has provided a number of years ago for a BIGA conference seminar a number of years ago. So here is the bed knife with the center line of the reel identified, and you can see the bed knife a little bit back from that. So you see when you tip that bed knife back, let's do it again. So here's the bed knife. If you tip that bed knife back, you see the whole reel dip into the canopy. So every time you move that bed knife, because the reel diameter is shrinking, and because you've spun grind too much, or you're backlapping and the reel bed knife relationship needs to be changed, so you move the bed knife back away from the center line of the reel to create the proper architecture in the alignment of the bed knife and the blade, that the reel itself tips into the canopy. And we did a study looking at the position of that bed knife relative to the center line of the reel, and found that in a 2-year period, when we had very stressful conditions that created opportunities for basal rot anthracnose to invade, we saw a clear relationship between aggressiveness of the bed knife and basal rot anthracnose, but it was a very short period of time. So what I tell people is, if you're at a time when your turf is under stress, make sure that bed knife is closer to the center line of the reel. Set up your mowers so they're not as aggressive. Now, the other cool thing that we found, we didn't find, this is what John and Tom Nicolai found in their recent work that they've published, is that in addition to some of the stress that we've seen, they see an increase in the amount of sand they pick up from the putting greens. So the more bed knife is moved to the back of the, further back from the center line of the reel, the more sand the reel was picking up. I thought, interestingly, they did not get much more clippings in the bucket. So it wasn't cutting more grass when they pitched it into the profile, but it was picking up more sand. Now, you can't have a conversation about putting green management without talking about the impact of rolling. And again, Tom Nicolai at Michigan State has pioneered the reintroduction of rolling as a tool for putting surface management. And you see in the slide below a really fascinating byproduct of rolling a putting green. It seems to control dollar spot. The plot on the right in the slide is the plot that was rolled and has the least amount of dollar spot. So we know there's a variety of reasons why rolling can be good, but what is the relationship between mowing, rolling, and green speed performance? We have done a number of studies over the last 5-6 years looking at plant growth regulator effects on green speed. We've collected clippings and we take ball roll measurements. And when we were applying the plant growth regulators using the growing degree day models that Bill Kreiser at the University of Nebraska established many years ago, we have not been able to demonstrate a significant effect of using growth regulators, especially Primo, for green speeds. Our use, the way we were using Primo and Trimmet and Cutlass growth regulators, we were not seeing an impact in green speed. But what we did see was what happens to green speed over a long period of time when you measure it 3 times a day. So you see this graph is a graph of green speed in feet from 9 feet to 12.5 feet over a 10-day period, okay? And we took all the data and crunched it into this slide. So this first number here is the data we take right after we mow. Then the second data point is right after we roll. So on the first day, we went from 9.5 to 11 feet. And 8 hours later in the day, even without a growth regulator, we maintained 11 feet. The next morning, we started at 10 feet, rolled it to 11 feet. 8 hours later, you see it drops down a little bit. And then it continues to drop the next day back down to below 10 feet, up to 11 feet, and then drop. And you see this pattern day by day. What we've noticed is, regardless of growth regulators or fertilizers or anything else, if you mow and roll, mow once, roll once, for 4 straight days, that's about as fast as those greens are going to get. They don't, at least in our work, have not continued to show faster speed by doing any more than that. Now, we experimented with this, looking at growth regulators and looking at a single mow followed by a double roll, or a double cut followed by a single roll. And what we found was, again, I believe rolling matters more than mowing. You have to find a mowing height that works for you, that you can sustain, and then roll. Because when you look at double cutting versus rolling, you see what happens. So here is, the red line is a double cut and the blue line is a single cut. So the first 2 data points is ball roll distance that we collected, or green speed that we collected right after we mowed. And you were 9 inches faster when you double cut versus single cut. And it was significantly better. But after you double rolled, it came almost exactly to the same speed as single rolling the double cut plot. So if you think about it, in this middle time here, when we took ball roll on this time, right after we rolled, all the plots have been rolled 3 times. One plot was mowed twice when it was rolled twice when we mowed. One was rolled once when we mowed, because mowers have rollers. But when you roll them all 3 times, there virtually isn't any difference, and virtually no difference in the afternoon. There is a 6-inch difference where you double cut, but golfers cannot tell 6-inch differences on putting greens when it comes to ball roll. So finally, as I start to wrap up my time with you today, I want to introduce you to something we've been experimenting with, and that is the idea of brushing the putting greens as an alternative to vertical mowing. And one of the things we've started to see by brushing is this scuffing and scalping of both bentgrass and POA. And when you look really closely, you see how much more open the canopy is when you brush. We have learned if you brush too much, you will kill the grass. So you have to use brushing strategically. And I believe when you begin to train your turf with proper brushing, you'll be able to eliminate many of your verticutting and grooming metal devices through the use of proper brushing. So that is something that needs more data. Now let me wrap up with the use of water. You'd be hard-pressed to talk about managing a putting green and not talking about water management. And so how do you audit your putting greens? How do you know if you're applying the right amount of water? Well, this again is a study that Bill Kreiser and Doug Soldat worked on at the University of Wisconsin on a sloped green, a green that was high at one end and low at the other. And they used the moisture meter that many of you may have to look at soil moisture, and at the same time did an analysis of the distribution of the irrigation system. So the uniformity of distribution for this soil moisture profile of this putting green, where point D is the high point and point B is the low point, the uniformity of the sprinklers was perfect. 80% is actually pretty good. But when you looked at the soil moisture uniformity, you saw that it was much wetter at the low end of the putting green. So if you're using your sprinkler heads, you're overwatering the low end if your sprinklers are applying it uniformly. If you reduce the uniformity of the sprinkler coverage, you actually improve the uniformity of the soil moisture. And so you see, if darker blue is wetter, so this is when the sprinklers are very uniform, and this is when the sprinklers are not very uniform, but the soil moisture is more uniform. I believe if you're going to irrigate your putting surfaces for maximum performance, you've got to use soil moisture sensors to adequately determine the amount of moisture those surfaces need. And of course, there are many sophisticated ways to do this. This is a collection of data that you can get from the Toro company. If they drive over your fairways, you can see the wet spots and the dry spots. And I believe as we start to move towards effective soil moisture monitoring that governs the way we irrigate, this type of mapping is going to be crucial. So thank you very much for joining me today for this webinar. It was great fun. I hope I did not drive Carlota crazy, and Chabi is still hanging in there with me. My hope is you have a little bit of a better sense of the science of the way plants are growing, a little bit of a better sense of soil management, and a little bit more about mowing, rolling, and cultivation and irrigation. So with that, Javi, how do you want to do the questions? How do you want to go from here, pal?
Hello, Frank. Thank you
Hello.
very much. Thank you very much for your presentation. It was really interesting. Right now there are no questions. I suppose that the attendees must be thinking about it. So let's give them some.
And you know something, Chabi? We can,
Tell me.
if they want to send questions about the presentation for a little while, for a few days afterwards, send them to you. You can translate, and maybe we can come back and either do an interactive little
Okay,
webinar, or
right.
I can try to answer them by email. It might be nice at some point to have a discussion if they
Okay.
want.
Okay, thank you very much. I appreciate it. There is one question from Antonio Miranda. He's a course manager from Portugal.
Mhm,
He's asking about top dressing. What do you
mhm.
think about, what's your opinion?
Top dressing, I didn't spend much time on it. Top dressing is the most important soil management practice that you conduct. Every study shows us now that regular sand top dressing is the best way to manage organic matter at the surface. And if you don't manage organic matter at the surface, you will not have good putting greens, period. So while I did not talk about top dressing specifically, I'm glad you asked the question, because top dressing, as all my soil colleagues tell me, and I agree, is the most important soil management surface preparation practice you can do. Even if you don't cultivate, you don't even have to make holes through cultivation if you top dress effectively. The challenge is, how do you match your top dressing with your growth? How do you match top dressing when you're using growth regulators? How do you find the right kind of sand to put in the putting surface so you don't pick it up with the mower? How do you find the right amount of sand so it doesn't disrupt play? There are many factors. Top dressing is its own 1 hour presentation. I'm sorry I didn't include it in this. It is the one thing you should be paying attention to, not how much fertilizer you should apply.
Okay, great. No more question. Let me, if you agree, let me say some words in Spanish.
Go right ahead.
So we will give them some more time. Nada, recordaros que, aprovechar para, si queréis hacer preguntas, pues las trasladaremos al doctor Frank Rossi. Si no, lo que haremos será, hay alguien que me ha preguntado acerca de la presentación. Frank, usually we load up the presentation in this session in order that people or attendees can download it. So I don't know if you agree to offer your presentation in PDF format
Mm-hmm.
so that attendees can have it.
Of course, of
Yes.
course.
Okay. I haven't put in the session because the file is too heavy and it doesn't let me to do it.
Okay.
So the people that may be interested in having this presentation in PDF, you can ask me and I will
Yeah,
send
that's
you.
correct. Mm-hmm.
Okay. So Frank, there are no questions. So I think that everything is shocked about your presentation and excited, and they are still thinking about it.
Or confused,
Or
maybe.
confused,
Yes, or confused.
maybe. Well, let's finish at this point. So let me check it. No questions. So again, thank you very much. I think that it has been a really interesting presentation. So thank you very much. I hope we can collaborate in the near future again.
I would like that. Nice to meet you. Thank you, Carlotta. Have a happy day.
Okay, so thank you very much.